Good morning, class. Today we're going to learn about light. Light is a form of energy which is radiated from a source and is detected by the eye. Light is a member of EM waves which is visible to our eye. Electromagnetic wave. Electromagnetic wave require a medium doesn't require a medium for propagation. As we can see from the picture, the wavelength goes from short to long, and the shortest wavelength is gamma ray. It goes in order into X-ray, ultraviolet, visible ray, infrared, microwave, and radio wave. Now, if we have longer wavelengths, then that means that we have less frequency, as frequency is the amount of wave per second. Now, we can see the parts of the wave. On top we have the crest and then goes to the wave trough. From one crest to another crest, it is called as wavelength. And from crest to trough, it is wave height. Amplitude goes from wave crest to the sea level, or just wave trough to the sea level. Natures of light. 1. Light as a particle by Sir Isaac Newton. He presents corpuscular theory of light, where light consists of tiny particles or corpuscles which travel along a straight path. Now, along the natures of light that is particle, it is considered into reflection as the bouncing of light and refraction as the bending of light. Now, long after Sir Isaac Newton passed away, there's another scientist called Christian Huygens that presents light as a wave, with the wave theory of light. Light is a series of frequencies of electromagnetic waves whose wavelengths vary from 400 nanometer to 700 nanometer. The electrons were behaving like a wave. The stripes were consistent with an interference pattern. This had already been observed in water waves. For instance, where two ripples in a pond meet, they interfere with each other, causing the similar interference pattern that was observed with the particle nature of light. There is refraction, where the light bends, and reflection. Dispersion. Dispersion refers to the separation of white-colored light into different colors of a spectrum due to the refraction of light as it passes from one medium to another. So when we have white light, as it passes from the boundary between the air and the glass, the prism is the glass, it will bend. And then when it bends as the white light, it will still bend to another boundary that is between the prism and the glass. Then it shows the spectrum of the light. Now, each light has different wavelengths, thus having different angle of refraction. And then the rainbow shows. Dispersion has color addition and subtraction of light. Color addition is the mixing of colored lights, where lights of different colors are mixed. Different color effects are observed. Now, when we have primary colors, that is red, green, and blue, when we mix the light of red and green, we will have yellow. Red and blue, we will have magenta. Green and blue to have cyan. And when we mix all of those colors, we will get white, whether it's from red, green, blue, or those all colors. Color subtraction refers to the removal of some frequencies of light. As white color of light passes a color filter. So when the white color passes the red filter, we will have red, orange, and yellow. The rest of the color will be cancelled. For green filter, we will have green, yellow, and blue. And finally, for blue filter, we will have blue, indigo, and green, and the rest will be cancelled. Finally, if we use red filter and blue filter together, the white color of light, when it passes red filter, it will result in red, orange, and yellow. But when red, orange, and yellow passes through the blue filter, it will all be cancelled. Results in black. Black has no wavelengths, as black is the absence of light. Calculating the frequency, wavelength, and the energy carried by light. V equals to the wavelength times frequency. C as the speed of light in the vacuum also has the formula of wavelength times frequency. The speed of light in vacuum is 3 times 10 to the power of 8 meter per second. Energy has the formula of h times f, frequency. In Planck's constant, h is equal to 6.63 times 10 raised to the negative 34 joule second. Now, leading to the common questions. Why is sky blue? The sky is blue due to a phenomenon called ray-light scattering, which is the scattering of electromagnetic radiation. In this case, light is a form of particles of a much smaller wavelength. Sunlight is scattered by the particles of the atmosphere, which is the oxygen gas and nitrogen gas. And what comes through down to Earth is called diffuse sky radiation, and though only about 1/3 of light is scattered, the smallest wavelengths of light tend to scatter easier. But as human eye that is more sensitive to blue color, we can only see blue sky instead of violet nor indigo. Next question. Why do we see colors of surfaces like blue? Blue object is blue because the object reflects dominant of blue wavelength and absorbs other colors. Another example of color is hair, as seen black, because it absorbs all visible light wavelengths, and paper as white, because it reflects all the visible light wavelengths. But our eye retina have rods and cones. 3 types of cones sense 3 types of colors that consist of red, green, and blue. As blue wavelength enter our eye, the cones that detects this blue send signals to our brain recognize color as blue. And lastly, is it better to wear black colored shirt or white colored shirt during the hot weather? During a hot weather, it's better to wear black colored shirt, as white reflects visible light and black absorbs visible light. Heat comes off a person's body from sweating. When all body heat hits white, it sets reflected back to the body. Black absorbs energy from sun and body. It also radiates the heat. Characteristics of light. 1. Reflection. 2. Refraction. 3. Diffraction. Is the ability of light to pass through tiny slits on barriers. And interference is formed when 2 or more light waves overlap. When we look at the picture, we can see there's a source of light, and there's the wall as barrier. At first, diffraction happens since there's one slit of it, and after there's two slits, the two waves overlap, where interference occurs. Now, there's two types of interference. There's constructive interference, where the interference has longer amplitude. And for destructive interference, the amplitude turns zero. Reflection of light. Types of reflection. 1. Regular reflection. It occurs in smooth surface, as light rays that are parallel to each other, and the image formed is clear. Opposite to it, we have diffuse reflection, where it occurs in rough surface. The light rays are in random directions, and the image formed isn't clear. The law of reflection. As the incident ray, the reflected ray, and the normal lies on the same plane, the angle of incidence is equal to the angle of reflection. Refraction of light. Refraction of light is the bending of light as it passes the boundary between two media of different densities. The law of refraction. The incident ray, the reflected ray, and the normal lie on the same plane. The ratio between the sine of the angle of an incident and the sine of an angle of refraction is a constant. Index of refraction. Ratio between the speed of light in a vacuum to that in a medium. N is equal to C over V. Snell's law equation made it as Ni sine angle of incidence is equal to Nr sine angle of refraction. Now, as we can see from the picture, there's the refraction of light, as there's a source coming through one medium, and it bends when it goes through the boundary of both medium. In this picture, it moves towards the normal. Hence, the angle of incidence is bigger than the angle of reflection. When we have denser medium, and like when it passes through the boundary to the rarer medium, the angle of refractive goes away from the normal. And when we have rarer density goes to the denser object, the angle of refraction goes closer to the normal. Critical angle. Critical angle is the angle of incidence in a medium, which makes the angle of refraction equals to 90 degrees. The formula is shift sine 1 over n. As you can see from the picture on the most left side, the angle of incidence is smaller than the angle of critical. And in the middle, we can see critical angle is equal to angle of incidence, which makes the angle of refraction 90 degrees. And finally, on the right side, we can see that the critical angle is larger than the angle of incidence. Total internal reflection happens when angle of refraction exceeds 90 degrees due to an angle incidence in a medium which is more than its critical angle. Examples include fiber optics, endoscopic optical imaging, etc. We are now going to have the practice question on reflection. Now, when we have an angle of 120 degrees and this source makes 20 degrees, which means the incident angle is equal to 70 degrees of AB. 70 degrees. it will then bounces off. So this will be equal, as this is the normal. So this will be a 40 degree, which makes the angle of reflection equals to 50 degrees. So there we have it. This will also be equal 50 degrees. Next. What is the shortest distance for eye to see image L? Now, if we want to know this distance, we need to count this angle first, as the tangent of this angle is equal to the opposite over adjacent. This opposite is 120 minus 50, which is 70, over 140. So tan theta is equal to half. And as we know, this is half, this is half. Since this is parallel to each other, so this angle will be equal to this angle. So this angle, half, is equal to the tangent of, the tangent of this angle, which is half, will be equal to opposite over adjacent. Now this, we don't know the adjacent for now, but we know it is smaller than 140. But from this, we can know that it is 50 times 2, so it's 100 centimeters. Smaller than 140 centimeters.